Let's see how to solve this question. In an intelligence test administered to 1000 students, the average was 42 and standard deviation was 24. We need to find the number of students exceeding the score 50 and number of students scoring between 30 and 54. So here we need to find the number of students who gets marks more than 50 and who get marks between 30 and 54. So to solve this question, let's analyze this once again. So here as per the question, n is given as 1000, m is given as 42 and sigma is 24. We are asked to find out probability that x greater than or equal to 50 means number of students scoring more than 50 marks. So first of all, we need to convert this into a standard normal variate. So for that, we give the substitution z equal to x minus m divided by sigma. That is equal to x minus m is 42 divided by sigma is 24. Suppose this is 1 because we need this later. So to draw this one, first of all, we need to convert x to z. Therefore, when x is equal to 50, z is equal to 50 minus 42 divided by 24, which is equal to 8 divided by 24, which is 1 by 3, which is 0.33. Then, therefore, probability that x greater than or equal to 50 is equivalent to probability that z greater than or equal to 0.33. So, let's draw a standard normal curve for this. Therefore, remember standard normal curve, both the sides will be symmetrical to each other and this the center point, this will be the mean. Therefore 0 and standard deviation is 1 and area to the left side of 0 is 0.5 and area to the right side of 0 is also 0.5. So here probability that x greater than or equal to 50 means you need to find probability that z greater than or equal to 0.33. So 0.33 being positive comes to the right side of this 0. Suppose it is here. So we have to find probability that z greater than or equal to 33. That means you need to find this area. Number of students who got marks greater than or equal to 50 means who got this part. So that is equal to find it. We know from 0 to this will be, you will be getting this by subtracting this value 0 to infinity, that is 0.5, and this value 0 to 0.33. So that is area under the curve from z equal to 0 to z equal to infinity. No need to write this one. In fact, you can write it as directly 0.5 minus area under the curve from z equal to 0 to z equal to 0.33. So that is equal to 0.5 minus, now z equal to 0 to z equal to 0.33 value is given by 0.1293. This is equal to 0.3707. So number of students who scored more than greater than or equal to 50 is given by n into p. That is n equal to 1000 into 0.3707, which is equal to 370.7, and being the number of students, you will take it as 371. So 371 students got more than 50 marks. Now the second part, probability that x lies between 30 and 54. So here also we need to convert this x into z. So from this equation number 1, which we have, when x is equal to 30, z equal to 30 minus 42 divided by 24, which is equal to 12 by 24 minus 0.5. And when x is equal to 54, same way you will get z equal to 50 minus 42 divided by 24, which is 12 by 24, that is plus 0.5. So we need to get, therefore, probability that 30 less than or equal to x less than or equal to 54 is equal to probability that minus 0.5 less than or equal to z less than or equal to plus 0.5, which is equal to, so just draw a diagram of that. This is 0. Suppose 0.5 is here and minus 0.5 is here. So we need to get z lying between minus 0.5 and plus 0.5, means you need to get this area, which is equal to area under the curve from z equal to 0 to z equal to 0.5. This is now area from 0 to 0.5 and area from 0 to minus 0.5, both are same. So either you can write this as it is area under the curve from z equal to 0 to 0.5 plus area under the curve from 0 to minus 0.5, both are equal. So instead of writing it twice, we can write that is equal to 2 times 2 into that. So that is equal to 2 into 0.1915, which is equal to 3830. 3830, and therefore number of students scoring number of students scoring between 30 and 54 is n into p, that is 1000 into 0.3830, which is equal to 380